Predicting the Future, One Roll at a Time. Written by Neil deGrasse Tyson from the Hayden Planetarium. Imagine trying to predict the weather. It's complex, right? Countless variables interact in unpredictable ways. This is where Monte Carlo simulation comes in. Named after the famous casino, it helps us make sense of uncertainty. Instead of relying on a single, potentially flawed prediction, Monte Carlo simulations run thousands of trials. Each trial uses random inputs based on probabilities. By analyzing the results of all of these trials, we get a range of possible outcomes and their likelihood. It's like rolling dice thousands of times to see what numbers come up most often. Monte Carlo simulations are powerful tools for decision-making in the face of uncertainty. They allow us to explore a wide range of possibilities and make informed choices, even when we can't predict the future with certainty. The building blocks of chance sampling, repetition, and probability. At the heart of Monte Carlo simulation lie three key concepts: random sampling, repetition, and probability distributions. Random sampling involves selecting inputs randomly based on their probability of occurrence. Think of drawing names out of a hat, where each name has a different chance of being picked. Repetition is crucial in Monte Carlo simulations. We run the simulation thousands of times, each time with a different set of random inputs. This allows us to explore a wide range of possible outcomes and their likelihood. Probability distributions define the likelihood of different inputs occurring. For example, if we're simulating coin tosses, the probability distribution would assign a 50% chance to heads and a 50% chance to tails. By combining these three elements, Monte Carlo simulations create a powerful framework for understanding and navigating uncertainty. Monte Carlo in action, from Wall Street to rocket science. The applications of Monte Carlo simulations are vast and varied, spanning numerous fields. In finance, investors use them to assess portfolio risk and predict stock prices. By simulating market fluctuations, they can make more informed investment decisions. In project management, Monte Carlo simulations help estimate project completion times and budgets more realistically. By factoring in uncertainties, project managers can make more informed decisions and mitigate risks. Even in fields like engineering and healthcare, Monte Carlo simulations have proven invaluable. Engineers use them to design safer structures, while healthcare professionals use them to model disease spread and test treatment effectiveness. Rolling the Dice, a step-by-step guide to Monte Carlo simulation. Performing a Monte Carlo simulation involves a series of steps. First, define the problem. Clearly define the question you want to answer or the system you want to model. Next, identify the variables. Determine the key inputs that influence the outcome and their probability distributions. Then generate random inputs. Use a random number generator to create a large number of random inputs based on the defined probability distributions. After that, run the simulation. Input these random values into your model and run the simulation thousands of times. Finally, analyze the results. Analyze the output data to understand the range of possible outcomes, their likelihood, and key insights. By following these steps, we can use Monte Carlo simulations to gain valuable insights into complex systems and make informed decisions in the face of uncertainty. Pie in the sky. Estimating pi with random numbers. Let's illustrate the power of Monte Carlo simulation with a fun example. Estimating the mathematical constant pi, imagine a square with a circle inscribed within it. The ratio of the circle's area to the square's area is pi over 4. We can use this relationship to estimate pi using random numbers. First, generate random points. Generate a large number of random points within the square. Next, count the points inside the circle. Determine how many of these points fall inside the circle. Then, calculate the ratio. Divide the number of points inside the circle by the total number of points. This ratio approximates pi over 4. Finally, estimate pi. Multiply the ratio by 4 to estimate pi. The more points we generate, the more accurate our estimation of pi will be. This simple example demonstrates how we can use random sampling and repetition to approximate complex values. Embracing uncertainty, the power of Monte Carlo. Simulations. In a world rife with uncertainty, Monte Carlo simulations offer a powerful tool for decision-making. By embracing randomness and repetition, we can gain valuable insights into complex systems and make more informed choices. Whether predicting financial markets, managing projects, or understanding scientific phenomena, Monte Carlo simulations empower us to navigate the unknown with greater confidence. As we delve deeper into the era of big data and complex systems, the importance of Monte Carlo simulations will only continue to grow.